Thank you so much for joining us today here in the room and online as well. I'm very happy to introduce you to Gusseppe, who is a computer scientist by training. He graduated from the National University of Engineering in Peru, and he is currently doing his PhD in artificial intelligence in Barcelona at the Universidad Polytechnic of Catalonia. He has several positions as data scientist and research engineer, most recently in the Barcelona Supercomputing Center. And he has been working on continual learning in different fields, and today he will show some of his work related with diabetes and eye images. Over to you, Giuseppe. Thank you.
Thank you guys for coming here. And now we were talking about how can continual learning and agents will accelerate health research. Okay. So,
Ram Jagannathan.
okay. So now I will just go into these technical details, but really like interactively. Okay. So feel free to scan this QR code. I mean, there you have these slides and all the content here. I'll give you guys in seconds. And the thing is that every like 3 to 4 slides, I will show a demonstration. So a real world demonstration, and I hope it works. So let's see. Okay, let's get started. So everyone's talking about AI. So I just wanted to know if anyone you have a clue, an idea what it is. Like maybe one word. So for instance, I will say learning. You have any idea what is AI? Everyone is talking about right?
Garbage.
Garbage, that's very nice. Yeah, I mean that's an agent, right?
Assistant.
Assistant, exactly. And to be an assistant, it should be like mimic like human behavior. Okay. Reasoning, vision, speech, and more. So this is like maybe like the Bible of AI. This is the book from Stuart Russell and Pierre Norbert said that AI is defined as the study of agents. So now we will talk about agents, these entities that receive percepts from the environment and perform actions. So kind of thing. So let me give you an example, okay? Like a real world study. Imagine we have this agent. This is a software agent, okay? And AI diagnostic imaging systems that takes some inputs like images, okay? And these are all the percepts. Okay? And the idea is to detect some patterns on these images. Okay, so this is like the task of this AI agent. And then the system marks those regions. Okay, so say for instance, this is the region where you might have some I don't know, some decision for instance, and it performs some action saying, okay, now I have my decision. This is the prediction. Okay. So this is an agent, a software agent that you will have in some software. Okay? But this is like not complete definition. I mean, humans have more features. Okay? So what I really like is the definition from psychology, particularly from this paper called 6 Lessons from Babies. This is a really nice paper saying that by modeling developmental processes, not just behaviors, okay, AI attempts to build agents that learn. First, learn, okay? Reason. Reason is like, for instance, you can infer, okay, something from some information. Communicate, this is language, speech, and adapt in changing contexts, as we do, okay? But it should be used to over time, step by step, bit by bit, okay, incremental, so that this can mimic human intelligence. So what I did is this graph, and I believe these features make this agent intelligent. Okay? So the green ones are the ones that we are going to talk this day, and these are like more things that an agent should have in the future. Okay, like for instance, exploration, like continual learning in a robot, be physical in a robot. Okay, so be social. This paper says that behavior are social in the sense that it should communicate their ideas just to learn from the environment. Okay, that's the one picture. And we want also the agent to learn a language. Learning a language, it's just how this agent can manipulate symbols. So based on some just basic language like mom, dad, sister, it can just develop a higher order level of language. So that is the basic. So now you might have, for instance, when you study a field, some ideas of this field, but then when you study more, you will have complex idea. And that's the like the goal of language. Okay. Be multimodal. Multimodal is when, for instance, you don't only receive information by language, but also by images, signals. Okay, and also you have to touch. So this is what this agent should have also. And one of the most important is that it should be incremental. Okay, incremental is like you have to make agents learn in a curriculum way. Okay, maybe you first start just learning how to walk, then how to run, how to ride a motorcycle, and so on. Okay. So this is the roadmap for today. 3 topics with 3 demonstrations. Foundation models with 1 demonstration, continual learning, and the demo 2, and agents. Okay? This is foundation models. This is like more or less, I would say, a state of the art in this recent year. Okay? Imagine that we have all the data. I mean, when we start on internet, we might have websites with a lot of modalities, okay? Like text, images, videos, signals, speech, tables, Excel, semi-structured PDF, JSON, XML, code, a lot of things. But how can you make a model that leverages all of this data, but not, but by giving you, like the supervision? Because I mean, this is a lot of data. So you don't want just to take like from context, like I love the cat, and give like the label. Okay, this is a good sentiment, or the sentiment is positive. You don't want that because this is huge. There's like billions of tokens of words. So these foundation models is a way of learning with no supervision, a lot of features that then you can use for question answering, like these chatbots, for instance, this GPT or the Llamas chatbots, sentiment analysis for Twitter, for instance, when you want to just make an analysis of the tweets, say, okay, these tweets are just like comments, good reviews for Amazon trading comments, and so on. Implementing instructions, image captioning when you say, okay, what is this image about? So also it can help and more. So let me give you an example. In healthcare, imagine that in healthcare, we have a lot of data. We might have medical text, health records, images, results from laboratories, publication papers, okay? And the thing is how can we leverage of this data to do something else, okay? So with these foundation models, we can get these downstream tasks. So for instance, diagnosis, treatment, We can summarize papers, publications, records. We can interface, we can have interfaces for patients, like for instance, these chatbots. In biomedicine, imagine that we just fit this foundation model with a lot of papers of personalized medicines. So for instance, you have a disease, but maybe this disease like diabetes is like general, and then you have some papers from this year from a specific demographic information with a 13 range of age, ethnic group, and so on. So, but those are in papers. How can you leverage those data? So only you have to fit those publications, and then you can just ask some questions. Okay? And also for more things. Of course, you have to build some models on top of it. It's not just like directly. But the good thing is that you don't start from scratch. So whenever you want to train a model, for instance, you are training with diabetes with fundus images, then you want to train another model for X-ray images, you don't have to train from scratch because you have this foundation model that have been trained with a lot of medical images. So that's the idea. Okay, you have to have like a baseline. Okay, so here at Emory, at the Global Research Center, we've been working with this foundation model, which is CLIP. Okay, this CLIP is a language image model. So it has two modalities, language and image. Okay? And the idea is to map images and text into a shared embedding space. So the idea is to have similar concepts close to each other. So imagine that we have this space, okay, and we have some points. So we have this image from dogs and also this sentence, say, 2 dogs running across a frozen field. So what we want is that these two concepts with different modalities, which is text and images, should be close. So that's the idea. So that whenever we want to, for instance, when you search on Google, you put the text and you will find some images only related to that. So also that's really useful when you don't have labels. So for instance, if we have a foundation model for X-ray, okay, images. So with only text, you can find some X-ray, for instance, from the heart, and I mean, from this upper just side. I mean, I'm not a medical doctor, but I mean, with this sentence, you may have like related images, okay, by only using sentences. So here, for instance, we have this sentence said that an elephant in the Serengeti, and we have here an animal. Well, so these should be used apart from each other. Okay? So that's what we want. And what is that? Well, this is kind of technical, but the thing is that every point in this space is a vector of numbers, okay? So that we can do manipulations. So, for instance, one manipulation of this is just to find the similarity of this number. So, for instance, if you see here in the first sentence says mountain landscape, So we have this vector, okay? And if we see here, the first image should be something related with this sentence. So the vector numbers are similar. And you see here, 2, 9, 2, 1, okay? So that this is useful then when we train a model. Okay? Okay, going just directly to the point. Here at Emory, we've been working with fundus images. Okay, these are the images from Brazil and India. The data set from Brazil have more metadata than the Indian one. Okay, but the idea is to create a continual model so that, for instance, if you train a model with these images, then what happens if you put that model in another hospital, for instance? This hospital might have different cameras, demographic information, the age is different, and also might contain some noise. Okay, so the idea is not only just to train a unique model, but also just to make this more robust across domains. Okay, so this is the dataset. I will have some pictures from here, okay, like the embedding that we were talking, the label, descriptions, and so on. Okay. So now the definition that we were talking now is a little bit more interesting because we put the foundation models. Okay, in the foundation models, I think this agent can work from something. Okay, so the development of models of these agents should be faster. Okay, so that's why we want. Okay, ready for the demonstration. So let's see. I hope everything works fine. So cross fingers. Okay, this is the demonstration. Let me refresh. Okay. So it says, hello, I'm your friendly assistant. I'm going out to scan your current folder. If you don't say nothing, use anything, it just scans your folder. Okay. It found these three artifacts or files. Okay. The first one is a PDF. This is the paper. Okay. So you, as an expert, you might have some papers, okay, related with a data set. So this is the paper with this Brazilian data set. This is from this year. You will have all the description here. And then you have the metadata of these images. So for instance, the age of each patient, if it has diabetes, nationality, and so on. Okay, and also the images. Okay. So for instance, this is the PDF, okay, like this. So now that we feed this information to this foundation model, well, in the back end there is a foundation model, okay, that can be some questions as well. So now we can ask some questions. Okay, let me show you that this is the first level of autonomy, okay, which is the exploration and using the foundation model. We will have 3 levels of autonomy. Okay. Okay. So, for instance, we can just ask some questions later. For instance, here, who are the authors? So, in the backend, it uses a tool related to read that your source of information and reason about that. Okay. So this is easy. Okay, this is like, okay. Another question would be like, for instance, okay, I'm too lazy just to read all these papers. Maybe I can, okay, can you, could you, yeah, but only use like 2 sentences. Okay. So this is the Brazilian with the layer of the data set designed to consist of these images, demographic. Okay, simple exploration. For instance, okay, now let's interact with the metadata. For instance, how many patients? So as you can see, it uses a different tool because it can more or less reason about the tools that it has. Okay, so it says, okay, I have this quantity of patients that have diabetes. Also, you can, you can ask like one question, but we don't have, So for instance, we can just say like, okay, give me 2 random images like this. Image like this, so that then we can just show those images. So then we can just say that, for instance, show me this. Okay. So, okay, this is like the first level of autonomy regarding the explorations. Now we're gonna set up. Okay, please set up the foundation model. This is another foundation model. Okay. Okay, with this foundation model, we now combine all the images, the metadata, I mean, this is this CSV, and also the PDF into one multimodal, let's say, structure or data structure. Okay, and now we have all the things in just one structure. So now we can just do more things. So, for instance, I have here like an image which is really nice. Okay. Show me this image. Okay, as you can see, this image maybe you know, has some problem. So we can say something like, okay, maybe a description, right? This is the image. Description. Takes some seconds because this is not in the long-term memory. It's not in the cache memory, so this is like, okay. So as we can see here in this image, we have the level 4 of diabetes, okay? Which is, okay, well, I'm not a doctor, but maybe, I mean something happened here. So the thing is that, okay, you told me that based on this foundations model, this agent might have like some knowledge, even though it maybe didn't train with this particular phone's images. Maybe it hasn't trained with all its images, but it might have some like knowledge. So we can say something like, give me, well, this is like a fair shot prediction because we are not just training with these images of this image. Here. Okay, and it says 0, which is wrong. Okay, which is wrong because, okay, I mean, actually, I will just show later. The accuracy with, I mean, just without training is like 33%. I mean, but for a base model is okay because I mean 33 and just for nothing, it's okay. And then we will see that when we train this model, we can improve the accuracy. So now we can say, okay, like use my images to fine tune my another model, using this information based on the foundation. So the foundation model is a clip model. I mean, just to not get lost. This is this clip model, and then we're going to use these images to train based on that model. So on top of it, so it should be there. Okay, so okay, I just all these agents just to not only just give the score, but also like explain why fine tuning is good. So it just goes from this score to this score by only using these 2,000 images. Okay, and this is not. I mean, this is not like the like the normal approach that you have to train your model for hours or for days. It only takes minutes. Now I'm just speeding up this model, but actually it takes just minutes just to retrain because we are using the base model, which is the embeddings. So these are like a really fast data structure. Okay, and then it said, okay, why fine-tuning is good because we are using transfer learning. Okay, we are just transferring the knowledge from the foundation to this newer model, reduce training, improve generalizations. So now, use models prediction, to a model to predict. So now it gets better, okay? So that is the first demonstration, okay, which is the exploration and the foundation. So we have two more levels of autonomy. Continual learning. Well, this is the field that I've been working for a long time. This is the picture that I really like of these agents. How can these agents generalize over time? Okay, so this is like the definition. Okay? So may this model learn over time without forgetting what you have learned. So for instance, if you learn how to walk, and then if you want to learn how to ride a motorcycle or how to just run, you should leverage this past knowledge to transfer to this new skill, okay? And the thing is, we are forgetting. I mean, you don't have to forget how to walk. So that is the thing, okay? You have to learn all the time. So this is, for instance, in this health field, usually we have this model that learns from different data sets, okay? And it just gives you, for instance, images from some people related to a particular group and so on, okay? And then you end up having a model. But what we want is just to not only, for instance, focus on the product, but in the process. So here we have small data, for instance, from an department from hospital, and then we can use some strategies to improve this model by using other images and so on. Okay, so this is the continual learning. Okay. So, for example, imagine that we have this AI model to detect retinopathy. That we use data from other European nations, for instance. So it should be able to adapt if you give the model younger Asian patient images. Okay, and that's difficult nowadays with the models. I mean, that's really difficult because there are some technical just issues with the model, and we will, when this model learn some images, they try just to be in some parts that when this model just gets some new images, it cannot go to this part. Or if it goes to this part, it just forget this part. So that's what happens with this model. So this is what we want to do. We have this data from the hospital 1, and then it should be able to retrain this model from hospital B and hospital C, okay? But not using all the data because of some, let's say, privacy, we don't have the past data. Okay, so for instance, we train this model and I give this model to the hospital B, but you have to say, or you have to tell to the engineer that train the model, but you don't have to use my own data because it just leaves my hospital. So that's not, I mean, that's not the idea. So with these strategies, you can give the model as it is, as a binary, as an artifact, and then use their own data and this train. Okay, you then have to use, or just want to use my model again, and I'll give you my second binary, and then I give you just to fine tune that just starting. So that's the idea. Okay, and just to do that, we have to develop some strategy as well. I mean, the word that we've been working is this. We use this clip model, this foundation model, okay, to get some embeddings, okay? So then the idea of our work is that how can we get the most important point from this data? So for instance, this is the hospital A, and it has like 10,000 images, okay? It trained the model, okay? And then it gives this binary to the second hospital. But this hospital also has like, for instance, 2,000 images. It should train the model with these 2,000 images? Not really. What I just proved is that with some important point, we can just train the model like really fast and with similar accuracy. So that's what I just showed in past conference. And now this is under review, one word of this. And the thing is that imagine just training with 1% of the images, okay, and getting like similar results. So that's the idea of this. Because imagine having this model in cloud and then give access to different hospitals around the world. Can you imagine all the data that they will have? So it's a lot. So imagine just training with 2,000, 2,000, 10,000, 10,000. I mean, the server will be or I mean, it will be like really expensive also. I mean, just to train with a lot of images. So, I mean, a lot of things. So this is the technique. The idea is to get the most important point, save that into memory, and then train a Hydra. I mean, this is called like a multi-head model or a Hydra model, because this is a model with several heads. So one head for hospital 1, or for the domain 1, for the domain 2, and that's it. I mean, so that we have like a baseline, and then we have a specialized model for each one. Okay, and I mean, just with some evaluations. I mean, this model is like really light. It has like good performance. There are other approaches, and this is like what this is the approach, and what these results. Okay, this is in red is the approach, and in blue this is like the normal approach from the strategies. So I'm using the state-of-the-art strategies, but on top of it, I put my approach. Okay, so this is like the by default in blue, and this is with my the strategy that is agnostic to all the let's see strategy. Okay, so with this we got just this number which are like really good. I mean, like the point here. And also using another state-of-the-art strategy, we got also, and also I tried with 5 more strategies. So this one. Okay, now it's time for the demo 2. I hope we have time. Yes. Well, feel free just to ask any question because sometimes.
Can I ask a quick question?
Yeah.
So how what is the goal? So as you add more data with time, does it depend on whether the SAM was classified appropriately by the person who entered the data? So, for example, what is the gold standard of saying this is retinopathy or this is not retinopathy? Did a human do it or did a computer do it that you keep adding in there? And then my second question is, what happens if you have a very low quality image that you keep adding? Does the quality of the image and the quality of the adjudicator matter?
Exactly. So the first one for sure, I mean, the methodology is just to just put a set of data which is the ground truth.
Yeah.
And for sure, those are taken from the data. And the data set, for instance, in the data set says that those are just come from the expert.
From like ophthalmologist.
Exactly. So as an engineer, I say that is, I mean, that is the ground truth.
Okay.
Okay. So generation.
I wondered, so you mentioned your goal with some of the projects is to get the same accuracy with training just on like 1% of the data. But what is kind of normal, for example, with training an AI model for example, reading these kinds of medical images? What is kind of a normal percentage that you need for training?
For training,
For like good accuracy, like how many, like, for example, if you have 10,000 images,
oh, yeah,
how many do you need to kind of use for the training in order to get good accuracy for the others?
if you have all the resources, you can train this all. I mean, that's a good thing. And for sure, all will be like mostly better. But the thing is, in some particular context, you can train this all. Because you can put this model in edge devices, for instance, in our smartwatch. So it doesn't have the resources that this has. So the thing you have to just think of the trade-off. So for instance, this smartwatch just tell you, okay, you only have to use 100 images because that's all what my memory can allocate. So you have to find like the most important. But if you have the server, the supercomputer, yeah,
And how like the human training aspect, like how many, which percentage need to be kind of assessed by a human?
oh,
before you
okay.
can-
Well, maybe you are just like thinking in this 80% for training, for testing, right? Yeah, I mean, and there are like many pragmatic, let's say tricks. For instance, if you have enough, like a lot of data, with 95% for training and 5% for testing, so you have everything. If not, maybe you can use one. But that depends on. I mean, the goal is just to find a test set that is difficult for the model. It's not just like valuable if you only have to say 10 points, but are easy. That's not when you might find, oh no, I mean, maybe this is hard for you for the model. Maybe this is kind of hard. So you have to find like this, like 10% maybe, but like really hard. So that you can just evaluate. I mean, I'm just going for the second question. You have this model, and when you just improve your model over time, you have to test with this. That should be difficult for sure from the beginning. Okay, so should I mention that this is the demo tool? Okay, then.
I have a question before you start.
Go
Sorry.
ahead.
Excellent. You had a slide about picking a selected data set as one of your strategies.
Oh, this one.
Um,
This one?
something about like picking a small data set to train on.
Okay, this one.
Yeah, so prioritizing only the most crucial images. Maybe this is just like a technical detail for clip, but I'm just curious what that means. Like,
Oh, yeah,
how would I
that's
know what is the most crucial image?
Yeah.
I don't know what actually feeds into predicting well.
Exactly. For instance, in machine learning, there have been some work with, for instance, how can you say that a prediction is important? And people used to get this confidence level, like the probability of the prediction. For instance, if you are training a binary model, you can say, okay, this is the prediction one. And also, alone, you can give also the probability of that. So you might think about, okay, maybe because the probability is 98%, this is important. Okay? So this is like more or less like the idea. How important is top prediction? But for this case, it's a different thing. For this case, it's like, for instance, this one. This one. Which is more important? I mean, for this description, this point or this point? For this description, two dogs running across a frozen field, which is more this one or this one? Because it's closer. I mean, that's my idea. So that's what I just do behind the scenes, just to say that this image is most important because it's closer by calculating the singularity with the labels. So that's not good.
But you would train your model before you even know where you're gonna use it. Like what you're saying is more like I
Yeah,
know
I
I'm
do
gonna-
like a zero
Yeah.
prediction, zero shot prediction for instance, I give like this description. Two description because this is a binary model. So let's say an image that doesn't have retinopathy problems. And another description is like severe disease or level 4, something like that. So this is like this description. So that I take all my images and compare to these two descriptions. And then I have like a ranking with which are the closest to this description. And for me, those are my important and for each group. It's kind of confusing, but I mean, that's like the
Oh, yeah,
like,
thank you.
like the situation. Okay. The demo tool. Well, this is not so fancy, but it is, I just wanted to show like how can we do continual learning for on the domains. So for continual learning. Okay, so this is like what continual learning is. So for instance, we have 4 domains. Okay, we have Brazil as a country with this type of camera. I mean, the image taken from this camera. We have the second domain, which is Brazil, but taken with the Canon camera. Okay. Of course, with different camera, we have different resolution, illumination, noise, and so on. Then we have the images from India originally, and then with some noise, like for instance, Gaussian noise, shot noise. We put like some points, for instance, in the noise just to mimic a new domain. Okay. And this is similar to having like hospital 1, hospital 2, hospital 3. And the thing is that, yes, that's what we want. Just to leverage like these most important points to retrain or to update them. Okay, so this is the one that is from our approach, the platform. Okay. Well, this is not so fancy because it takes like more just units here. But just let me finish with this part. Okay, so we will have like 3 more slides and that's it. Okay, like more exciting this topic is agents. Okay, so at the beginning I mentioned I just mentioned agents, but what is an agent? Okay. So is it a program, an entity? What is this? Okay. So an agent is an entity that can just work autonomously, but it should achieve some goals. Okay. Here in this graph, I put like these 4 concepts. Okay. An agent has memory. Just to, for instance, if you say something to this agent, it can just recall those memories and just perform more things. Okay? Short-term memory and long-term memory, as we have also. It can have some tools. So, for instance, it can have one for mathematical skills, for coding, for fetching. In our case, I put a tool for training a model, to perform continual learning, to do explorations, to give some insights of the data and so on. And also it should plan. Okay. So for instance, if you say, okay, can you do let's say a macaroni, for instance. It should plan. Say, okay, maybe I need the ingredients. Which are the ingredients? Okay, pasta, tomato. Okay, and then I should turn on the I don't know, some artifact and so on. You see, so you have to do like the or this agent should do the planning. And also it should perform the action, which is like manipulation with this Emory. Okay. Of course, have you heard about these GPTs models? Okay, those are large language models. GPTs, Elmo, Llama 1 and 2, okay? But there are also foundation models, okay? And the good thing is that they can generate human-like text. For me, the most important feature is that they can reason. If you give some information, they can use that information to infer. Okay? Like all men are mortal, Peter is mortal, or maybe Peter is a human. So that's the kind of manipulation. So well, this is like the input. You give like a question, then you give demonstrations. So for instance, you give, okay, this sentence from a tweet, I love cats. And then you give some demonstrations. So for instance, I love pets. And you should answer positively. I hate cats. You should give a negative. So you give the question, the demonstration, and then you will get like the answer. Then with a new question, you will get the answer. So for instance here, answer the following mathematical reasoning questions. It gives, I mean, you have to give some demonstrations. Okay? So this is the question, and this is like the process and the answer. So whenever the model just find a new question, it can just follow the same process. So it's like teaching but not training, but just teaching just in real time. So that's what these large models can do. Okay. And finally, just to go to the demo 3. What we want is not only put all the let's see, the responsibilities to these agents. Okay, so it's important in this field, in healthcare, for instance, just to have some guidance. Okay, so how can human give some or provide some feedback to this model? And the thing is that there are many ways. Human can give some labels. So imagine that you have an image. Of course, this data set have with some labels, but maybe you have been working within the images, and maybe you might have more expertise. So you want to provide a feedback. So say maybe this is not the level 3, maybe this is 4. For sure, I'm pretty sure that it's 4. Okay, you can give some feedback and then give some metadata like explanation. Okay, I think it's 4 because of the community. And then whenever the model just receive a question, it can just take into the account this new feedback. Okay, and the good thing is that this model should align to human preference. If not, this cannot just be allowed to run in an application. Okay, so the thing is the collaboration, and they're amazing. But I mean, okay. This is the future work, the demonstration tree, because it just requires a lot of things. But I just wanted to show, because I forgot something like that, is that, okay, what question? Or where inside? It's like, for instance, you have your data, but you want like some plots regarding the data. So for instance, how can we just compare this with this? I mean, you tell me, what can I get from this data? So I'm not telling that just, okay, plot this variable with this variable. No. I mean, just feel free just to answer. So it will find insights. So for instance, okay, I can tell you what is the distribution of patient age, I can give you what is the distribution of variables. I can give you the distribution of this level of severity of variables. I can give you the distribution of quality, the images, and more. Of course, you can say, okay, give me only one question. So, the goal of this agent is that, I mean, we can put whatever we want. We can just make some tools like custom tools so that we can leverage like this, for instance, knowledge of these tools, and also we can use tools for searching on the internet, so that we can, I don't know if you feel like I mean, you can talk with a model and you have like many tools. So whenever you wanna just, I don't know, investigate or research about something, you have the flexibility just to ask questions, the flexibility to interact with your data. You can train your data just once and then, okay, let me just train with this second set. And you don't need just how to program, like, should I need Python? Should I need? Okay, yes, maybe, but it should be like the future, just to maybe take advantage of this agent, this reasoning capabilities, and maybe speed up maybe the discussion. So that's my goal of this talk. Thank you so much.
What makes it go from continuous learning where it's using data to being autonomous? What's the difference?
For the difference. Yeah, well, continuous learning is like a thing. Maybe it's like a feature, for instance, but to retain autonomous, you need like more features that continuous learning. So autonomous is like a feature that maybe requires like 5, 10 features. So autonomous, I mean, just it's like my car is autonomous. I mean, there are like 5 levels of autonomy, but this car requires like computer vision. It requires just to retrain the model with different domains. When you're in a city, in the city town, then you move to countryside, it should just adapt to the street. So it requires set of things. So autonomy is like a goal.
Maybe online? Yeah. Are there any online? It looks like there's one question. And
No, that's the wall.
oh. Anybody online have questions?
Oh, yeah, sorry.
I have a more general question.
Sure.
I wondered, so you were talking about like training of the data for example, a hospital, and then like how to, when you have this different hospitals, like, how do you do it, for example, if you train a model for some hospitals in the US and then want to use the same model for like clinics or hospitals in another country with different patient populations? Do you need to go through the whole process again, or can you use like quite some?
I mean, with no supervision, your model will detect maybe that you are giving or you are feeding these images from a different domain. With no supervision, your model will say, okay, I found a drift. Maybe this is not the images from the same distribution of the training. Okay, then you will see, okay, yes, I mean, you are right. As I told you, it won't take like all the data, just a particular one. Most of the process of continual learning are automated. So we can do like a process. As I did here in the demonstration, maybe just by just giving some text and some orders, so we can automate those things. So for instance, you can have in the cloud with your user and password, and you have your folder or your zip with your new images, and you only have to give like the task or or the seed, and then you use that. I want to use to train, I want to, that's what, that's efficient, to just give some order.
It's great.
But behind there are like many algorithms that makes everything just easier.
Yeah.
Yeah.
And just out of curiosity, like I know that many people are working on these types of models in like many places in the world. What does this environment look like? Do, for example, people at hospitals talk to each other and say like, oh, we have like developed this model to like analyze these types of images, and do they then share the model with other hospitals, or is it like all individual efforts? So,
Exactly, and that's what, for instance, in embedding, we don't share like the raw images. As you see here, these are only points, so other hospitals cannot see your data. So that's more maybe like the private.
yeah.
They're private images.
Yeah,
So-
no, then I get like in terms of privacy, of course you cannot share it, but would it be possible for example, another hospital, when they would be interested in a model like this, to use the model?
Sorry,
Like, is it now you like develop this model? Would other hospitals be able to apply to use this model in a way?
Oh, yes. No, what I just find interesting is this concept of federated learning. When you have one big model and every user, client, hospital, institution can just teach this model, but without sharing the data. So that's
Yeah.
like and that's another concept really close with the continual learning. The federated learning is just across, it's like distributed, but using continual learning. But that's mostly like the idea. But we need like some requirements. We need continual learning, embeddings, to encrypt the data and more things to do this. Just the federated learning.
Yeah.
But that would be good, right?
Yeah.
To have a hospital in the jungle that only have like internet access and can take images from a phone, from a smartphone. That would be like really nice. And also provides some images from this particular tribe or group that that are like really rare. And you don't find. It's like really nice.
Yeah, so many opportunities.
Very
Very nice work.
Yeah, exactly.